My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 587. In this lecture, we will try to understand architecture of Cbow. So, let's call my vocabulary as capital V. And let's say small v is the length of the vocabulary. V is length or size of the vocabulary. V represents the number of words that I have in my dictionary or vocabulary. This is step number 1. The second step is that I use one hot encoding to represent each word, which means given any word wi, I can represent it as v-dimensional vector. Wi belongs to r power v. Binary, this is binary vector. This is basically a binary vector of v dimensions. I request you to go through my previous lecture where I explained this one hot encoding binary representation of this particular words, isn't it? Because I have total of v words in my vocabulary, therefore your wi belongs to r power v. So given any word in vocabulary, I can always represent as a v dimensional, not real valued vector but binary vector. So let's start with this. As I told you, I request you to go through my previous lecture where I already discussed all these one hot encoding representation of words. Now let's draw the architecture first. So let's assume I have each of these boxes. Let me say this is anyway step number 1. Step number 2, just see, I have, let's assume each of these boxes is a v dimensional one hot encoded word, isn't it? Think of this as an input layer. I can say this one as an input layer, is a input layer in your system. Each of these is a v dimensional vector. This is what is your input. I can say this is your input. The first input is context word C1. Yes, what is my input? My first input word is context word C1, which is just try to recall what we were keeping here. First one is C1, second one is C2, last one is CK. Means how many context words are there? We are assuming there are k context words. First context word is a v dimensional vector. Second context word is also v dimensional vector. Even kth context word is also v dimensional vector. Just try to recall this sentence where we are assuming f means focus word or target word. C1, C2, C3, C4, C5 are known as context words. Let me assume I am keeping C1 in first box, C2 in second box. In similar manner I can represent CK, isn't it? What is the idea here? What you have to do here? Just see here, I will represent on on as a one hot encoding, and I will put it where I am keeping on in first. It's a first context word, isn't it? This is binary vector representation. We know how to represent on as a binary vector. Just refer my previous lecture. Again I have context word 2, I have context word 3, so on. How many context words I have? K context words I have. So I have k context words. So in Cbow, what we will try to do is this. The core idea. What is the core idea? The core idea of Cbow is this. Given context words, can we predict the focus word? Because we agreed that there is a lot of information about the focus word that is present in the context words. There is a lot of information of focus word, that is target word, which is present in the context word. So the core idea of Cbow is, given context words, let's try to predict focus word out of it. My input is context words. What is the input? Input is context words. What would be the output? My output is focus word, isn't it? Let's assume all of these are connected to a n-dimensional hidden layer. Let's say this is an n-dimensional hidden layer, and this hidden layer has linear activations. What are the activations here? Linear activations, not sigmoid activations. What is linear activation? Linear activation is if you input z to it, it will return z. That is f of z equal to z. Just try to recall what is my z. Z equal to w transpose x. All those things we discussed in our previous lectures, isn't it? There are n units here. How many units in this particular hidden layer? There are n units here. So this is fully connected. This is fully connected. This is also fully connected, so on and so forth. This kth one is also fully connected. How many weights are there? How many weights are here? There are v values here, and there are how many values in C1? There are v values in C1, isn't it? That is context word 1, whose binary we have its binary representation. We have v values. How many values in hidden layer? I have n values in hidden layer. So total is, what is this? V cross n. There are v cross n weights. Let's call this v cross n weights as w1 or w power 1. The w power 1 is of order, it's a matrix of order v by n. W power 1 is all the, what is w power 1? Is all the weights which goes from my first context word C1 to my hidden layer. What about my w power 2? My w power 2 again is v cross n, isn't it? So capital N here is dimensionality of hidden layer. So remember, what is v? V is the dimensionality. V is the size of the vocabulary. V is the what if v is very, generally v is very large. I can say v could, how many words you can have? Even you can have 10,000 words in v, may be 10,000 words, isn't it? What is my input layer? I have input layer here, isn't it? This is my input layer, and I have my hidden layer, isn't it? Let's see what is my output layer. So what do I want to do? I want to predict. So what do I want to predict? I want to predict, this is my input layer, this is hidden layer. Just say I want to predict, I wanted to predict the focus word, which is a vector of size v dimensional, means your word belongs to r power v. What I need in final layer means what? My output layer. What do I have to predict? From this, basically I will get my output, isn't it? What will I get? I will get output, isn't it? I will get my output. My output here needs to be v dimensional binary vector, isn't it? Your output is v dimensional binary vector, because I am trying to predict focus word. That is important. What is our intention? We are trying to predict focus word, because focus word is represented as a binary with one hot encoding, isn't it? Focus word is also represented as v dimensional binary vector. That is focus word. So the activation units that I use here is basically, what activation unit I can make use here? I can make use softmax, isn't it? This is again fully connected, isn't it? My softmax layer, my what is softmax? Softmax is generalization of logistic regression. From this output, only one of them is set to 1 and rest all of them are set to 0. So you can think of this problem is like predicting the focus word, isn't it? What is the intention of Cbow? You have to predict the focus word, that's target word. You can think of it as multi-class classification problem, because you are trying to predict one word out of collection of v words, isn't it? So that out, so that there are so that so that out belongs to, isn't it? So what is this? What you are trying to do here? Let me repeat. Because you are trying to predict one word out of collection of words, so that it belongs to any one of these V words. So this is your architecture. This is architecture of Cbow. So you have softmax here. You have softmax layer in soft. You have V activation units. How many activation units have here? It has to generate V dimensional vector, isn't it? Here, because it has to generate V dimensional output. Here, this is there is this connectivity here. Let's call it as W of n cross V, because you have n units here, n units input here, and you have V units output, isn't it? Therefore, because you need softmax of V units, isn't it? In this softmax, you have V units to generate a V dimensional output. This is structure of Cbow. I can say it is structure of Cbow or architecture of Cbow. Very, very simple. You have an input layer, you have hidden layer, you have an output layer, isn't it? Just look at the number of weights. Let's assume you have huge. What you have to do? Let me assume you just look. You have huge. Let's assume you have a huge repository of text, isn't it? The way you train the Cbow is this: you take your whole text. Just take whole your text repository. You take all of your text. Take your Amazon food review text. Take all Amazon reviews text. Take all of this text. Now create the combinations of focus words and context words, isn't it? See, for example, just take that same sentence which we discussed. What is this? My focus word is, what is my focus word is here? Sat. And my context words, what are the context words? The cat on the wall. If my focus word is cat, my context words are the sat on the wall, isn't it? So I can create lots of those combinations of focus words and context words. So this become my training data. This is, I can say, capital D, my training data. So given text repository, given repository of text, I create data set of focus words and context words, isn't it? Create this particular data set. I train this neural network or my Cbow neural network. This is very, very simple neural network. I can train this Cbow neural network using this particular data set, capital D, isn't it? After training, what can I get? At the end of the training, what do you have? I have all of these weights, isn't it? Just see, I have all the weights. I can say your W of n cross V. You can find all these weights. After training, what will you achieve? Here you have weights, isn't it? Here this weights, this W power 1, W power 2, so on, W power k. At the end of the training, you can find at the end of the training, what do you have? I have all these weights. At the end of the training stage, I have all of these weights. Now, if you look at these weights, what is this? This is W of n cross V. W of n cross V means what? It's the n by V matrix. There are n rows and V columns. We were discussing that this is a V dimensional. What is the output of this one? You will get V dimensional vector. This is basic architecture of Cbow. I request all of you to go through this particular lecture. If you have any difficulty, please keep a comment. Thank you very much.